This is the second video for graphing absolute value equations. We're going to start off with the big idea, the whole point, the general equation of an absolute value equation. We had numbers out here that multiplied the absolute value and they did stuff. We had this number right here which affected the x move, left or right, and we had this number out here that affected the y move, up or down. So I don't have names for these other than A, H, and K. I did say that I would call A slope, but that's not strictly speaking true. It acts like slope on one half of the graph and not on the other, but it will give you the same sort of idea as slope. It gives you like a rate of change that it will go up or down. So first, let's talk about this A value. It has a couple of things that you need to consider. Is it positive or is it negative? And if it is positive, then it means that this thing is going to point up, it's going to open up. If it's negative, that means that it's going to flip and it's going to open down. So that's one thing that the A value does. You have to look out for that plus or negative. The other thing that it does is acts like a slope. So the higher, as A gets higher, then it gets steeper, and as A gets lower, it gets wider. Now that's all while it's still positive. The same thing happens if it's negative; it flips. So those are the two things that A does. It says it either opens up if it's positive or it opens down if it's negative, and it acts like a slope just to give you the steepness. So then we've got the H and the K move. Now the H and the K move, think of it as your vertex is at the point H, comma, K. Let me switch colors here because it's going to start all running together. So the vertex is at H, comma, K. Alright, so what's up with the difference in signs in this general form? Well, remember that whenever there was the y move and it said plus, plus moved up. So a positive k value goes up and a negative k value goes down. Now for the h move or the x move, the h value, let me move this down here. If the h value is minus h, that goes to the right. Now that seems different than you would expect. When it was plus h, it moved to the left. Also different than you would expect. Why? I think that it is the opposite that you would expect, and that's because if you had a coordinate axis, then this is your positive x over here, this is your negative x, this is your positive y, and this is your negative y. So your x's behave differently than you expect, and your y's behave the same as you'd expect. Well, your formula actually tells you this. Think of this as an opposite sign. Think of this as a same as sign. So the k value moves to the right, the k value moves up when it's positive and down when it's negative. Alright, now we're going to put this to practice. Here's an example. It has all of the different properties. It's got an a value that's not 1, it's got an h value and a k value. So the first thing you're going to do is figure out where the vertex is. Well, remember that the vertex is at h, comma, k. Well, h is negative 3. Your k is 2. Is that what you would have expected? Well, think about it. If you started with your parent function's vertex at the origin, 0, 0, this moves left 3 and up 2. Left 3 and up 2 puts the vertex right there. The h value is the x-coordinate of the vertex, negative 3. The k value is the y value of the vertex, and that's positive 2. So we're employing that opposite thing. I see a plus 3, but the formula says a negative. So think opposite of this, negative 3. Think same as this, 2. Opposite of this, negative 3, same as this, 2. Okay, so we are mostly done. We've got the vertex. So the only thing we need to do is now go to the A value. The A value is positive, so it's going to open up, and on the positive slope side, it rises 2 and runs 3. So go from the vertex, rise 2, run 3, and let's do that one more time. And then we are going to go back to the vertex and go the opposite direction. We're still going to rise 2 and run 3, but this time we're going to make sure our slope is the negative slope. So our graph looks like this. Now it is symmetrical, but I just ran out of room over here. It does go infinitely far up to the left, just like infinitely far up to the right. Okay, now I'm going to give you a chance to try. I've got a few of these. I've got 3. You try it, so you can see it on your paper if you have a handout in front of you. So try each of the first 3 and then come back to the video and see how you did. Okay, these aren't exactly done, but they're going to be done pretty quickly because I have graphed the most important point on these next 3 graphs. I've graphed the vertex. So you must identify that the parent function that had a vertex right here had the vertex slide to the right 5, and it went up 2, so it ends up right there. So you've got the vertex. The next thing you're going to do is go over here to the A value. It opens up, and it has a slope of 2, so that's not the right spot for it. So we're going to go rise 2, run 1, and then we are going to go from that point, rise 2, run 1 again, and that covers one side of the graph, and then we go to the other side and put in a couple more points. And it'll look like this. Okay, next one, my vertex is graphed already. Here's the vertex of the parent function. It'd be at the origin, but I'm going left 2 and down 3, so it ends up here. Then go to the A value. Now I'm going to just leave this point hanging out there for a second. My A value says -1, but you know what? I don't need that 1 there. You had to know that that negative means a -1. So it flips down and has a y value, or sorry, an A value of 1. So it goes here, here. That's like a slope of 1. And then on the other side, a slope of -1. Actually, that's quite the opposite. On the right side, it's got a slope of -1. On the left side, it's got a slope of +1. So that A value describes the slope on one side, not the other. So our graph looks like this. Last one of this type. The vertex was translated from the origin. It had no x move, but it has a y move that's down 1, so that points there. I'll leave that hang out for a second. Then I go to my A. It points up, and I rise 1, 2, 3, 4, 5, and run 2. Now it's from the vertex, not from the origin. And if I do that again on this side, it's off the graph. I'll just go over here. Now you might notice that through the vertex, there's this this axis of symmetry. I've not drawn it yet, but I could just take this point right here and just reflect it over this axis of symmetry. Now this is a good one to discuss that because the y-axis is acting as my axis of symmetry here. It means it flips over that. It's like this is a mirror. This distance would be the same as this distance. I've got 2 more try it functions. It's this one and this one. You try to figure out what the function is and write it down. And once you try, come back and see if you got it right. So here's our first one. It opens down, so I've got a negative. The slope is 1 because for every rise of 1, I run 1. Remember, rise could go down, just a negative rise. Rise 1, run 1, do it again, 1 over 1. So my slope is -1 over 1, or that is to say my A value is -1 over 1. My vertex is +5, -1. Remember, think opposite of this, that's +5. Think same as this, that's +1. So to the right 5 and up 1. One more. Okay, here's our last one. It opens up, so my A value is 1. I'll worry about the 1/2 in a second. First, the vertex. You slide the vertex over here. It goes to the right 2, so that's -2 grouped with the x value. And it doesn't have a plus or minus anything over here, so it doesn't have a y move up or down. So the translation is just 2 to the right. Then you look at the A value. Okay, it opens up and you rise 1, run 2, rise 1, run 2, and that's your positive part. And then you reflect those over. Here would be my axis of symmetry. Okay, not that. This would be a picture of my axis of symmetry. So I'm flipping this point over there. This point is getting flipped over there. And that's just a quicker way to graphing it, perhaps, than going back to the origin and going up 1/2, up 1/2, just in the opposite direction. Okay, that is it for graphing absolute value of equations. Now I'll give you some practice to try on your own.